application area for our Applied Remote Sensing Training Program. I also work with NASA's Western Water Applications Office, where we work to address issues in the Western US related to things like droughts and floods. And finally, I am the lead for a couple of projects that we have been working on with the Navajo Nation. And I'll talk a little bit more in depth about that as well. So good.
Okay, now I finally figured out where my camera, all of these different applications are different, right, in terms of how they work. So anyway, so I'm going to get started with our presentation. So I just want to talk a little bit about our Applied Sciences program and let you know all the different topics, because we're only talking about a couple of the topics today. So there may be other things that are of interest to you. As I said, I'm an associate program manager for the ecological forecasting program, but we also have disasters, wildland fires, health and air quality, and Amber is mentioned the water resources program. And then Amber and I are both connected to the capacity building program, which is really where our Indigenous Peoples pilot project is kind of lands. And so that's what I'll be really talking about the most here is our capacity building program. So within that program, we have 4 different elements: SERVIR, RSET. Well, they all have their acronyms, right? NASA's really good at acronyms. So SERVIR is our international capacity building program. It's a joint program between NASA and USAID. So I'm not going to focus on that today. But RSET is our remote sensing training program. So you can find a lot of training materials available freely to you through RSET, and I'll give you a website in a second. Develop is our internship program, and then we have our Indigenous Peoples pilot project that I'll tell you a little bit more about. So this program we started this about 5 or 6 years ago to really understand more what the needs are of Indigenous peoples, both inside the US and globally, and to really figure out how to understand better how Earth observations, specifically satellite Earth observations, might be useful to Indigenous communities, and combining that with, community engagement and then Indigenous knowledge systems, and how do we bring all of those things all together. So in the last 5 or 6 years, we've been helping to build the capacity of Indigenous peoples to use satellite Earth observations to monitor and manage their natural and cultural resources. And we've done that through a series of workshops. Of course, pre-COVID, they were in-person workshops. And you can see some of the locations that we've done our workshops, all the way from, Bellingham, Washington, to Michigan, to Albuquerque, New Mexico, and so forth. And so we co-designed those workshops with the tribes in those regions to not just do like a canned kind of workshop, where we actually design a workshop around needs, geospatial needs that they might have in those particular regions. But then COVID hit, right? So all of that in-person workshop stuff stopped. And Amber and I decided to put all our material online to make it freely available to tribes and other organizations. And so we collaborated with the United Tribes Technical College in Bismarck, North Dakota, and put together this 4-week series on basically how to do remote sensing for a variety of different topics that you can see here. So we cover land cover classification, change detection, and so forth. And each of these sessions include hands-on exercises that you can follow through. So if any of you are interested in learning more about how to use satellite imagery, I encourage you to visit the site. The website is here. Again, everything is freely available, including the data and the exercises themselves to download. The really fun thing that we did with that particular series is every week that we offered our courses, we prefaced our training courses with some kind of a video from tribal members around the country that have used geospatial data for a variety of uses. And so these are just examples of some of those stories that were told to preface each of our training courses. So to me, that was really fun because we got a really great view of how people were using it in their own language, in their own words, and made it more, I think, relevant to tribes in the US. The other thing that Amber and I are very involved with is something called the Indigenous Mapping Workshop, which you all might be interested in as well. This is actually based, organized by a group called the Firelight Group. They're Indigenous owned in Canada. So it's been run out of Canada, of course, in person for several years now, maybe 6 or 7 years now. And then last year they went virtual. And it isn't just remote sensing. Actually, we just started including remote sensing in that just last year, but it's, primarily it's a collaboration between the Firelight Group and Esri and Mapbox and Google and other kind of geospatial companies to talk about data and technologies for Indigenous peoples. And so it really includes the incorporation or bringing in and including Indigenous knowledge and language and the cultural aspects of Indigenous communities to these workshops. So I highly recommend that you take a look at that as well if you're interested. That workshop will be held again this year in the first week of November. And now I'm going to turn it over to Amber to talk about a tool that she's developed with the Navajo Nation called the Drought Severity Evaluation Tool. Okay, Amber, over to you.
Great. Thank you, Cindy. And thanks again for this opportunity. Great to be with you all. So I'm going to talk a little bit about our relationship or partnership with the Navajo Nation Department of Water Resources to create this online web tool that really showcases the use of NASA Earth data alongside ground-based information that there is using to monitor drought across the nation. This project has been a collaboration with NASA, with the Desert Research Institute and the Navajo Nation. So we're really glad to have this collaborative work. Next slide. And it's really important to start off in the context of building the relationships and talking about the connection of the Navajo people to their land and their knowledge system of water resources, water availability, water distribution, and pulling that piece in and having that piece being really integral from the start of this project. This began many years ago when Cindy and I traveled to the Navajo Nation to have these discussions. And what came out of those discussions was really an internship, a couple of internship programs where we had groups of students who began this work together, and it's really evolved into something larger. But it all began with that first meeting and those first discussions, and communication is really key. So I think that's what we want to bring home here as the starting point for the basis of this work. Next slide. And I think we'll skip, we have this great resource, and I'll provide you all with mine. But through the creation of this tool, we've had Danae interns working. One of my interns, her name is Nikki Tooley. She worked really hard on this communication piece, and we created an in-depth user guide that provides an overview video, which is what we have here, but I think we'll skip. I'll send you all the link to watch it as well. But it provides an overview of the project, and then it also provides case study examples and demonstrations of how to use the tool. And the introductory video is also provided in English and partially in Navajo as well to make that cultural connection. So I'll provide you with those links as well. Coming back to our project and our tool, to provide you a little bit of an overview, I mentioned this started as an internship program, then it got picked up by NASA's Western Water Applications Office to be funded for a couple more years to really increase the usefulness of this tool. And now part of it being funded through the Bechtel Foundation, so we can continue these collaborations with the Department of Water Resources and the Desert Research Institute. Next slide. What we really wanted to produce with this project was a user-friendly web application that combines remote sensing data with information about the Navajo Nation, their administrative boundaries, their precipitation records, in order to make maps and time series of drought indices, of climate data, of a variety of things that would be useful for drought reporting and for the declaration of drought emergencies as we are in now, and I'll talk a little bit about as well. But the idea here was to really provide a tool that's easy to use, that's accessible, that doesn't require a lot of downloading and processing of any of the satellite data. Next slide. So this is what the DSET tool looks like when you come to the main page. DSET is a spinoff of a really popular tool called Climate Engine. I don't know if any of you have heard of that. Climate Engine uses Google Earth Engine as sort of the back workings of the tool. And then it has this really great slick user interface where along the left-hand side, the user can select different types of climate variables and the type of statistics they would like to run, like totals or percent of average statistics. And then all within this interface, you can click on Get Map Layer and generate maps for specific regions. And Climate Engine is actually available globally. And our spin-off tool has much of the same data as Climate Engine, but we've really focused in on the Navajo Nation and included some of their data into the tool that could be used for map making and things like that. Next slide. So as I mentioned, the ability to produce maps in this easy interface. This image on the left shows you an example of the Standardized Precipitation Index, or SPI, which is the primary index that is used by the Navajo Nation to make drought emergency declarations. So we can look at things like the SPI in the map form, but also run time series analysis to compare things like vegetation health and precipitation, or precipitation and a drought index. And we can look at this over time and see how these things have varied. Next slide. So I mentioned this tool is a spin-off of Climate Engine. We really wanted to make this tool useful for the partners, so we adapted it to meet their needs. One of those needs was to include their network of 85 rain gauges across the nation. And you can see those here with all those little red geolocator markers. That's the location of all the rain gauges. You can see a cluster of them in sort of the central region of the nation in the Chusca Mountains. These rain gauges are visited on a monthly basis by the department, and on the ground, total precipitation measurements are taken. And so what we can do then is we can take a look at these ground data sets and look at them alongside some of the estimates from our satellites, like precipitation estimates. So this is one feature that we were able to really highlight and use their data as well. The other thing that you'll notice is the outline of the Navajo Nation, along with the boundaries of their 110 chapters, which are similar to US counties. And one feature that we were able to do also was provide some of the data as area averages over each of these chapters in order to really where the drought is more severe across these administrative boundaries. We have the option to also select things like their 5 agencies, similar to US states, mountain ranges, or the entire nation whole. Next slide. So we really focused on a variety of different drought indices, and these drought indices come from a combination of satellite data from NASA, as well as modeled data and ground-based data. And so they're really used to create these estimates of severity of drought. And it depends on the index, what kind of variables you're going to look at, but some of them just use precipitation. Some of them pull in things like evapotranspiration or the amount of water being used by plants, or things like temperature anomalies. What we're using is the standardized precipitation index, which is what I mentioned. The nation uses a 6-month SPI to make these drought emergency declarations. So that's really the marker. The 2 models that we're using are CHIRPS and GridMet. Again, these combine satellite data with modeled data. Next slide. And there are other drought indices that we're exploring the use of, and our partners are also thinking of how to include these in their drought contingency plan, which they're currently updating and working on now. And these include the SPEI, the EDI, and the Palmer. And these, again, use a variety of variables, but evaporative demand is a really important one, especially in fast-moving droughts. And that's included in things like the EDI. Next slide. So to give you a little bit of an idea of the current state of the drought, things are changing rapidly because in the past couple of weeks, there have been some large monsoonal rains in this region. So the drought has actually improved a bit, but there have been issues with things like flash floods. But this is an image from July 9th, where we calculated the 6-month SPI over the 110 chapters. And you can see that the drought is severe in 4 chapters in the southwestern portion of the nation. And this image was actually, a similar image was used to declare a drought emergency in late on the nation. Next slide. And we could also look at something like the change in the SPI over each of the 5 agencies, which is what you can see here in this graph. And this is through from January through July of 2021. You can see sort of here at the end in July where the SPI has actually increased due to some of those rains that have occurred recently. So this is all in quick order. You can do this analysis in the tool. You can download the data. You can download the image of the figures as well. Next slide. And we are continuing our work. We are moving beyond just our DSET tool. We're doing capacity building efforts, some training efforts with other groups on the nation, like the Fish and Wildlife Department and their climate change initiative. And what we're really moving into now is looking at consumptive water use through this new tool called OpenET, which looks at evapotranspiration across irrigated agricultural fields. Next slide. ET is really useful for measuring things like water budgets, for looking at how to conserve and incentivize farmers to use less water. It can also be used for transactional activities of water exchanges, and really to look at on-farm efficiencies. And so what the ET value provides us is of consumptive water use on a field scale level, which is really, really valuable. And it uses satellite data to provide this information. Next slide. The OpenET Data Explorer is slated to be launched pretty soon, in the next few weeks, I believe. This is a really large team of scientists across the nation working on this for a variety of applications. Our Navajo Nation case study is just one example. but this is what the interface will look like. I've zoomed in here to the Navajo Nation, just near the Farmington area, where you can see these large-scale center pivot irrigation fields on their nappy farmlands. And we can look at how these consumptive water use rates are changing over time on a monthly basis. Next slide. Great. So with that, that'll end our presentation today, and we really want to pose this question back to you all and potentially have a conversation about how satellite Earth observations could be used for the work that you're doing, that you're interested in, and we're happy to provide more examples. There are so many examples of how to use these data, but it's all about this discussion and feedback loop to see what's useful for you all and then what we can do. So we just thank you for your time. Our email addresses are listed here. You can follow up with us as well with any other questions. So thank you so much.
Yes, thank you, Cindy, and thank you, Amber. You might want to check your chat boxes real quick to see if there's any questions. Also, if anyone's calling in and you have a question, you can email me and I will be glad to forward the questions on to the ladies. So I don't see any questions just yet in the chat box. Do you guys see anything in your chat box?
No, I'm not seeing anything, but we'll stay on for the rest of the session too. So if you have questions as things go along, then please feel free to, send chat in the chat box or again, email us. We're really, we really want to figure out good, really collaborative ways to work with tribes within the U.S. And we have a lot of things coming up in the next year that might be of use to you. So we want to make sure to get that word out to you. So thanks again, Karen, for inviting us. And we look forward to hearing the other presentations.
Okay, thank you, Cindy. I appreciate it. Okay, for our next speaker, we have Dr. Kirsten DeBeers with University of Oklahoma. And I will unmute you so you can start your presentation.
Thank you so much for, can you hear me?
Yes, we can.
Perfect. Thank you so much for inviting me to present today. I'm sorry that we have some technical issues, but I hope it will work over the phone in this way. I really appreciated the previous presentation as well. This is a very interesting session to have together. So my name is Kirsten DeBeers. I'm a professor in the Department of Geography and Environmental Sustainability at the University of Oklahoma. I have a PhD in Natural Resource Sciences from the University of Nebraska, and I've been at the department for a little over 11 years now. At the university, I teach courses on the use of satellite imagery. As part of these courses, I familiarize the students with the Google Earth Engine, which is a handy tool to monitor land use change, but can also be used to analyze weather, climate, burnt areas, and more. I believe that this tool might be handy for others outside of the university as well, especially those who are familiar with GIS datasets. And today, I would like to introduce you to this tool with a practical application, and I would like to propose and invite you to a larger workshop. Next slide, please. So there are petabytes of freely available geospatial data for every area around the world. And we already heard about some of these data sets from the previous speakers, which is really awesome. However, it's often still difficult to find all the different data sets and then download them and work with the data sets in a local environment. For Oklahoma, we're not just talking about satellite observations such as Landsat, Sentinel, and MODIS data, but also vector data such as Tiger files, as well as terrain, land cover, weather, and climate data. Next slide, please. Organizing geospatial data is part of Google's mission. One of the fundamental goals of Earth Engine is to organize all those geospatial data sets and make them accessible and useful. Next slide, please. The most efficient way to make the data accessible and useful is to move the question to the data. What this means in a nutshell is that instead of an organization downloading large amounts of data, a system should really be developed where people can work with the data they're interested in without needing to download the data. And I think we saw an example of that actually in the previous talk as well, which was great. Next slide, please. In order to move the question to the data, Earth Engine hosts a petabyte-scale archive of satellite imagery and other geospatial data on Google infrastructure. At the same time, Earth Engine provides an API in order to perform processing, analysis, and visualization of the data, also using Google machines. Data storage and processing are all performed at Google. You connect to the servers through a web browser. While this might sound very promising, it is my experience that users can really benefit from a workshop-like introduction to the system before starting to experiment on their own. I have proposed a 1.5-day workshop to help introduce you to this system. During a short introduction discussion in March with a small group of people, I learned that there was an interest in a 1- or 2-day workshop, preferably on a Thursday or a Friday. I also learned that there was some interest in learning more about land cover changes, as well as calculating area statistics based on shapefiles. Next slide, please. After this discussion, I've developed the following workshop plan. First, on Thursday afternoon, I will provide you with a general introduction to the Earth Engine. You will learn how to find, filter, access, and map data in the Earth Engine. Then on Friday, we will first work on a guided exercise mapping land cover change and climate or drought. We will also calculate area statistics using vector and raster data. On Friday afternoon, I will be available for further questions, and hopefully I will be able to provide some answers. I will also provide a few example tutorials. Next slide, please. I will start by introducing you to the Earth Engine code editor. The workshop is hands-on, and you will get to practice working with the code editor in guided coding exercises, and you will see immediate results. Next slide, please. For our first workshop, we will focus on the Wichita, Caddo, Delaware, Oklahoma tribal statistical area. The total size of this area is more than 2,500 square kilometers, or just over 600,000 acres. In the remainder of this talk, I will discuss a few data sets that are easily available and accessible for this area. During the workshop, we will introduce you to these different data sets, and you will be able to analyze these data sets on your own and under our guidance. The Earth Engine also allows you to upload vector data sets if they are not already available. In this case, I have uploaded the shapefile with the Oklahoma tribal statistical areas. Next slide, please. Let's start with available aerial photographs from the National Agricultural Imagery Program. These images first became available in 2003, and since then, most of the continental USA was flown first every 5 years and then every 3 years. NAIP imagery are acquired with a 1-meter ground sample distance. Older images were collected using 3 bands, red, green, and blue. But newer images are also collected with a near-infrared band, which is very helpful for vegetation analysis. Above, I show the latest NAIP image from 2019 for Binger here in Oklahoma. There are 923 NAIP aerial photographs available for the entire Wichita, Caddo, Delaware tribal statistical area, with aerial photographs for all years. To generate just the 2019 map, a little more than 100 aerial images would need to be combined. Next slide, please. With just a few lines of code, the Earth Engine is able to collect 107 NAIP images that cover the tribal statistical area in 2019 and plot the imagery to the screen. Images can subsequently be used to digitize or to do analysis with it. It is also possible to download data if you would like to. Next slide, please. This is what it looks like on my screen. Note that on the left side, you can see all my scripts. I've organized those scripts into different repositories for different projects and classes. The middle panel shows the code for the current presentation, and the console on the right prints information about the images I'm showing. The map at the bottom is the same map as I showed in the previous image. The data is overlaid directly on the Google map, so it's easy to interpret where you're at. The small Layers tab in the top right corner of the map allows you to turn layers on and off in a similar way as you do in other GIS software packages. Next slide, please. However, it's not just the true color data that is available. We can also, with one line of code, or a little menu click, change the imagery to a false color composite, which helps in identifying well-growing vegetation. In addition, we can ask the Earth Engine to provide us with an overview of the available imagery and the years. In this case, there are data available for 9 different time steps between 2004 and 2019. Next slide, please. We can do the same with other types of data sets, such as the national land cover data shown here. This data set has a 30-meter spatial resolution and is based on Landsat data. The data is available for the entire United States. Instead of downloading a large portion of this data set, we can easily pull the data into Earth Engine and map it. But what if we want to calculate some statistics? Next slide, please. With a few lines of code, we can calculate the total area for each of these land cover classes in our study region. Next slide, please. We can similarly investigate the USDA National Agricultural Statistics Service cropland data layer, which provides an overview of the different crops at a 30-meter grid cell on an annual base. A quick analysis reveals that our selected study region lost more than 35,000 acres in grasslands, and that the amount of acres in cotton more than doubled from just over 11,000 acres to almost 23,500 acres. The increase in area under cotton production is a trend that is visible in other areas of Oklahoma as well. The map, which shows cotton fields in red, reveals that most of the area with cotton can be found in the western part of our study region. Next slide, please. It's not just satellite data or land cover data that's available. The entire record of the U.S. drought monitor data is also available in the Earth Engine and can easily be mapped. Here I show the latest data available from July 20, 2021. Next slide, please. Earth Engine can also generate simple graphs of the data at any location with a click of a mouse. You can download the time series of one grid cell as a CSV file as well if you want to generate a better looking drought graph. This one, of course, doesn't look very good. This graph, however, easily shows the exceptional drought that this particular region in Oklahoma experienced in 2011 and 2012. Next slide, please. There are many other drought indices available as well. For example, this is the GridMat's Palmer Drought Severity Index, which is available from January 1980 to last week. The data is updated regularly. This is a time series for a 5-kilometer grid cell just north of Binger, and also shows the drought in 2011 and 2012 clearly as negative values, with a pretty good recovery in the last few years. The inset image shows the drought condition according to the Palmer Drought Severity Index. Next slide, please. With that, I'm currently looking for 2 things. First, I would love to receive an email if you're interested in being put on our workshop participant list. And second, perhaps most importantly, I'm looking for people to host a workshop. If you're interested in hosting a workshop, I will be happy to travel to you. All we need is some small classroom or conference room space, ideally with enough seating for about 10 to 15 people. We also need to make sure that we have good Wi-Fi internet. It will help if participants can bring their own laptops, but if no laptops are available, I can likely bring about 5 to 10 from our department for the duration of the workshop. With that, I will end my talk. Please get in touch if you would like to learn more. Thank you, guys.
Thank you, Kirsten. I appreciate it. You might check your chat box and, well, I don't think you can, but if anybody has any questions for her, please use the chat box, or you can email them to me and I will be happy to go ahead and forward those to her. Our next presenter is Josh Worcester with Fort Sill Apache. And Josh, I am giving you presenter privileges so that you can share your screen. Okay, Josh, you have the floor. Josh, I don't think we can hear you. You're unmuted, Josh.
Okay, can you hear me now?
Yes, yes, we can hear you now.
Okay, all right. I just had to call in. I'm not sure what happened.
You
well, my name is,
need to mute your computer. There's a little bit of background noise.
Okay, is that better?
We can still hear echo.
He's gonna need to turn the volume down on his computer.
Turn the
Uh,
volume down on your computer and use your phone.
Okay, how about now?
Yep, that's better.
Okay, all right, thank you. Sorry about that, everybody. But my name is Josh Wooster with the Fort Sill Apache Environmental Program. I manage the water quality and air quality programs here, and also the drone pilot. So it's just a little information about the EPA programs. We're funded through the EPA, of course. We have a GAP program, air quality, 106 water quality, and the last 2 years we've been operating a drone program as well. So the drone, we wanted to get it so we could perform checks on the tribal owned lands that we have, for any concerns related to solid waste, water quality, and air quality. We also can use it for educational outreach events. And then, there's our future plans, including GIS. So the drone was purchased through our transportation program.
Josh, do you have
approached us-
PowerPoint?
Yes, I am.
Okay, you're not sharing your screen.
Oh, okay. Well,
Sorry, I hated to interrupt you, but I thought you had one.
oh no, it's fine. I'm just trying to get this. This is a
And you
different
do
computer
have
that I'm
presenter
using, so-
privileges, so you should be able to share it. Just make sure you have the
Okay.
PowerPoint like already pulled up before you hit share.
Okay, can you see that?
Perfect, there you go.
Okay, sorry about that. I'm sorry. Let me go ahead and get to here. Okay, so like I was saying, our drone was purchased through our transportation program. The tribe approached our EPA program here and was asking if anyone would be interested in learning about drones and operating them, and they kind of gave us a description of what they would want. And so me and Monty Scammahorn, our environmental specialist here, we jumped on it, and we went to the Cherokee Nation in Tahlequah and then actually attended a course pre-COVID So that was the first time, I'd ever operated a drone. It was pretty cool, So then when we come back, we're always thinking, well, what should we do next? We just did some investigating before we purchased ours. The Cherokee Nation had a DJI drone, and it seemed pretty simple, so we went that route. But the drone technology is rapidly evolving, and so as I stated before, I'm not sure if everybody heard me or not, but the tribe wanted to collect aerial photos of tribal lands and any road projects that they might have, so we could show to our tribal members. And but once we got the drone, there was a lot more that we could do with it than we initially thought. So there are 4 main classes of UAVs, and they are multi-rotor, and this is the most popular drone on the market. And out of the 4 main classes, these are the easiest to manufacture and the most economical to fly. But the only thing is these aren't suited for long distance flight. So if you're trying to survey or if you're trying to do some mapping or inspections, they're limited on their flight time. So these are probably not ideal for you. The multi-rotor is the one that we purchased for the tribe just because it was the best functionality for us. The next one is a fixed wing. These are capable of traveling very long distances, and so these are ideal for mapping. The majority of them are gas powered, and they can last in the sky for up to 15 hours. So, once we were looking at these, we was trying to figure out, well, that sounds pretty good, but we don't have a runway and we don't have a catapult to launch them into the sky, and that's what these require. Also, to get them down, you would need a parachute or a net to collect them. So we just didn't think it was ideal for the tribe. But the good thing about these is that they collect hundreds of thousands of photos and images during their flight. So they're really good for engineers, for contractors, and if you have the time and the space to fly them, these are really good, but they are costly. The next one is single rotor helicopters. Now these are capable of having longer flights as well, just because the majority of them are gas powered. There are some drawbacks to it. The long propeller blades that they have can be a safety issue, so you have to take special care in operating these. And these are quite costly as well because of the complex designs. They also require more mechanical maintenance. So once we found out that was the cause, we was like, I don't think this is the right one for us. The next one is fixed wing hybrids. So they're pretty similar to just fixed wings, but these can go lift off vertically instead of having to be launched. So it makes it easier to operate these, but these can be big ones as well. There's only a handful of these on the market at the moment. And if you can tell in the middle there, in the pinned picture, it's Amazon uses these drones to do their prime air delivery days. So this type of drone will become more advanced as technology develops around it, and you should expect to see more of these coming out later on. So why did the Fort Sill Apache tribe want a drone in the first place? Well, we wanted to quickly collect images of travel properties without having to locate on Google Earth or Google Maps or search engines like that. And we also wanted the capability of collecting images from travel projects in real time and as projects were completed. So how could a drone benefit an EPA program? Well, you could use it to locate solid waste dumps. We use it to check our waterways for illegal dumping or for the damming of water, which has happened before. You can also use it to inspect burning on tribally owned lands. And so there's just a number of different things you can do with the drone. And now you can even collect samples from them, water, air, stuff like that. Those are, of course, more advanced. But, I mean, the possibilities of using them just keep going. So what drone was best for the Fort Sill Apache tribe? And we chose the DJI Mavic Pro 2, which was the one similar to the Cherokee Nation had. And it was fairly easy to operate, and I was more familiar with this one, so that's why we went ahead and chose it. And we also purchased the Mavic 2 Fly More kit, and it came with everything that you see there. It has extra blades, battery charging hub, also has a car charger and extra batteries. Those extra batteries allow us to gain more flight time as we're operating the drone. Drones can last for 20 to 30 minutes in the air, depending on how hard you're flying them and if it's windy and stuff like that. So having these backup batteries allows us to fly more, to collect more data, to collect more images, and to complete tasks easier. So once we got the drone, it was time to put it to use. We've used it around our complex and our other travel properties, and in the future, there's other things that we'd like to accomplish with this drone. So I have a short video here that I'm gonna play real quick. I don't know if you'll be able to hear it or not, but I'm gonna go ahead and play it. So just the video just had some pictures and video, of course. But I mean, there's a number of different things that you can do with this, and it's just like I said, the technology is growing more and more. So in 2 years and 5 years, there's no telling where this technology is going to take us. So all the pictures and videos that are taken are evaluated, and we're made it readily available to tribal members and tribal council. So our future program goals is, of course, to map out our tribally owned lands. The Fort Sill Apache tribe has tribally owned lands in Oklahoma, New Mexico, and in Arizona. So we hope to gain better imagery from those lands, and also to gain a better understanding of our waterways in our tribal jurisdictions. This allows us to fly along the creeks and see if there's any soil erosion, of course, any damming. So it's just another tool that we can use to make our jobs a whole lot easier instead of having to go in there by foot like previously. And that's the end of my presentation. I'll put my email in the chat box if everybody can read it. And if you have any questions about drones or anything like that, just please let me know. All right, thank you.
Thank you, Josh. Josh, you might check your chat box just to make sure no one sent you a question. I don't see any in our chat box. And Cindy, if you want to check yours, and Amber's, if y'all want to check your chat boxes real quick. I just don't want to miss any questions. Josh, did you see any in yours?
No, there was one just before I was able to share my screen, but other than that,
Okay,
that was all.
thank you. Cindy or Amber, did you guys see any chats in your?
No, Karen, I'm not seeing any questions here either.
Okay, okay.
None for me as well.
Okay. Okay, then, well, if anybody has any questions after the fact, they can always send them to me or Chelsea, and we will forward them on. Thank you so much for the presenters today. We appreciate you guys coming in and presenting for us. And thank you for everyone that attended the session this afternoon. So our next session will begin at 3 o'clock, and it's the first aid training / field safety. So you guys be sure and join us again at 3 o'clock. And with that, we'll sign off, and everyone have a good afternoon. Thank you so much.
Thank you.
Thank you.
Thank you.